Um, this Here we are going to describe the course content of engineering statics, which is ID 1130, which is taught in the first year of BTech Mechanical Engineering and Civil Engineering. I am Dr. Ashok Kumar Pandey from the Department of Mechanical and Aerospace Engineering, IIT Hyderabad. My email ID is ashok@iits.ac.in. The course content for this engineering mechanics course is divided into 5 parts. In the first part, we will talk about particle, rigid body, deformable bodies, and we will also discuss about some basic principles related with the mechanics of these uh, bodies. Then we will talk about the different laws which are used to find out the resultant of like the forces which are acting on either particle or rigid bodies or deformable body, and those theorems or laws are parallelogram law, triangular law, vector addition or subtraction. We will also discuss about the equilibrium state of a particle and rigid body, and also talk about the supports and the reactions in this particular section. And then we will also talk about, in the second part of this particular course, we will talk about trusses, frames and machines. We will do force analysis using method of joints and method of sections. Special attention will be given to zero force members, and also we will discuss about the condition of a statically determined system, and we will do force analysis of frames and machines briefly. Afterwards, we will go to find out the internal forces, multi-force member and two-force member, where you will have in the multi-force member you will have normal or axial force, shear force and bending moment as the internal forces. And we will, before discussing about how to compute all these internal forces, we will discuss about sign convention for the different internal forces, and then apply the method of section to determine internal forces in beams mm, have having transverse load, or basically is a multi uh, force body. And then we will find out relationship between applied load, shear force and bending moment, and method of superposition to obtain shear force diagram and bending moment diagram. Afterwards, we will talk about frictions, basic concept of dry friction, how under equilibrium, how the dry friction really helps the rigid body to maintain its equilibrium. Then we will demonstrate the concept of friction uh, through an example uh, related with wedges, screws, valves, bearings, and we will also introduce the concept of rolling resistance. Finally, we will discuss about the concept of virtual work. We will apply the principle of virtual work to find out the static equilibrium of many systems. And afterwards, we will also talk about the center of gravity and centroid. We will demonstrate how to find out centroid of curve or wire, then how to find out centroid of area, how to find out centroid of volume. Then we will find out the area moment of inertia and mass moment of inertia. We will apply theorems of Popper and Gildias to find out, you know, to find the relationship between line and area, and also area and volume when volume is obtained by revolving a surface and area is obtained by revolving a curve. And then we will demonstrate these concepts through simple examples of geometries. Then we will also demonstrate parallel axis theorem and define how to find out polar moment of area and radius of gyration. Then we will apply some of these methods to find out moment of inertia, either area or mass, to composite structures, composite areas or volume. And finally, we will end this chapter. And finally, we end this discussion. The references for this particular lecture is basically Pierre and Johnson, Vector Mechanics for Engineers, Statics and Dynamics. This is what we are following most of the time. However, in some of the concept, we refer engineering mechanics, statics and dynamics by R.C. Hibbeler, and also engineering mechanics, statics and dynamics by Irving S. Shames, and Introduction to Statics and Dynamics by Andy Dewey and Ruddha Pratap. And We acknowledgement we in acknowledgement we are very thankful to Professor Yogi Desai, Director IIT Hyderabad, for motivating us towards flip teaching. Professor V. Ishwaran, Head of Department MA Department Mechanical and Aerospace Engineering, for his suggestions. Raghuram, Satish, Rahul and Vijay Chakravarti from the server room and computer section for their help in recording the lectures. A special thanks goes to Satish for his help through the recording session. A very warm thanks to all my BTech students of Mechanical and Civil Engineering who took admission in IIT Hyderabad in 2014. A big thanks is also due to my family as well as my friends for their support. Thank you very much. If you have any comments or suggestion, please do not hesitate to write to me at this email ID ashok@iits.ac.in. Thank you.